This lecture is on polynomial functions and their graphs. So a polynomial function is any function that is of the form an x raised n plus an minus 1 x raised n minus 1 and all the way up to a2x squared, a1x and a0. So as an example, here we have x cubed minus 2x squared minus 3x, and the coefficient here is a3, the coefficient there is a2, and the coefficient there is a1. So of course there is a0, but a0 is 0. And you can see that the subscript of a corresponds to the power of x. So here we have 2 and there 2, 1 here and 1 there. So there is a 1 because x raised 1 is 1. And here we have a sub 0, and this would be x raised 0, but we know that x raised 0 is 1. So, and in addition, 0 times 1 is 0. So the subscript here corresponds to the 0 there. So some of the facts about polynomials: all exponents are positive integers. So if we look at the previous example, or the example here, we have 3, 2, 1 and 0. Or to be precise, since we include 0, we should say non-negative integers, because we are including 0. So here the graph that we have is cubic, and it is a polynomial. The highest power of x is the degree of the polynomial. So in this example, x raised 3 minus 2x squared minus 3x plus 0 has a degree of 3, because the highest power in that polynomial is 3. So the coefficient corresponding to the term with the highest power is what we call the leading coefficient. An easier way to remember this as to why we call it a leading coefficient is because when we write 2x squared minus 3x, so we start at x cubed, so that is the first term, and sort of go down this way. So 2x squared follows x cubed, and x follows the x squared term. So x cubed leads the other two terms, hence we call it the leading term, and its coefficient the leading coefficient. So a polynomial of degree n would have n solutions and at most n minus 1 turning points. As an example, if you look at our curve here, it is of degree 3 and it turns twice, which is 3 minus 1, we have 2. So for the given functions, we want to know if it's a polynomial or not, and we have to determine its degree, the leading coefficient, the number of zeros and the number of turning points. So the highest degree here is 3, the highest power. It's 3, which would imply the degree is 3. And is it a polynomial? Of course it is, because if you look at the powers of x, they're all integers. I'm sorry, I actually made a mistake. The highest degree here is 7. It was an oversight. Excuse me, yeah. So it's better to write it this way. So 2x raised 7 plus 4x cubed minus 3x squared minus 4. This way you can see the leading term. So the coefficient corresponding to the leading term is 2. So the leading coefficient is 2. Since the degree is 3, this would imply there would be 3 zeros. And since the degree is 3, it would have 3 minus 1 turning points, and 3 minus 1 is 2. So the next one, we have 3x raised 5 minus pi times x raised 4, plus I could write 1 over x as x raised negative 1. If x goes to the numerator, the exponent becomes negative. So the 3x raised 5 is not a problem. Pi x raised 4 is not a problem. But that term has a negative 1 as an exponent, which is not permitted with polynomial functions. Therefore, this particular function is not a polynomial function. In a similar manner, if we look at the next function, we have x raised 1/2. So that is a fractional power or fractional exponent. This would imply not a polynomial function. We would want the exponents to be non-negative integers. So in this case, part D, we have negative 3x raised 6, negative 3x raised 5, and 18x raised 4. So the leading term here is negative 3x raised 6, and it has the highest power. So highest power is 6, which would imply the degree is 6. The leading coefficient is the constant in the leading term, so that would be negative 3. And the number of turning points, since this is a polynomial of degree 3, this would, excuse me, sorry, degree 6, this would imply 6 minus 1 turning points, which would be 5. Now, we can't say it would have exactly 5 turning points. That sort of is the maximum number of turning points the polynomial could have. And since the degree is 6, there would be 6 zeros. So the